All right, hello folks. I hope you're having a great weekend. All right, this recording is AP Calculus AP class. I'm going over one problem from handout number 7 and one problem from assignment number 13, Intermediate Value Theorem Practice, to help you complete the assignment. All right, so let's go over it. Right, so number 5. This is number 5 from the handout, number 7, folks. So we have f of x is equal to negative times half to the negative x plus 3 minus 2. Oh, really funky looking guy, right? So this function, we want to figure out if there's any c value, right? Any x values in the interval of 3 and 5, closed interval 3 and 5, that when I find f of c will give us negative 4, right? So this is what you do with IVT. But first of all, there are two conditions that needs to be satisfied so that we can use these IVT, right? So let's take a look at it. First of all, exponential function is continuous for all domain of the x over here. There are 4 different types of functions that we know that are continuous over all x in this domain, and that means no hole or no asymptote or no break, and so those 4 are going to be, if I have to mention it, is polynomial functions. There's also trig functions, trigonometric function, okay, and then there's also going to be exponential function. And there's also radical function. So radical function is not continuous for all x that are real numbers, but within its domain, for example, it might look something like this. Within this domain, not including this endpoint, everywhere else is going to be continuous for the radical function. Okay. And trig, you folks already know, is periodic function, right? And not all trig functions, though, have to be careful, actually. Sine, cosine functions, okay? And then exponential functions like y equals 8 to the x power will look something like that, right? And then polynomial function like x squared plus 3x plus 2. Then you have something that looks like a parabola, or depending on the power of it, it might be, like x cubed will look something like this, right? Yeah. But nonetheless, the most important thing is it is continuous for all x are a real number for first 3, and then radical for domain. No hole or break. So we can safely then, when we see exponential function here or polynomial function or combination of that, right? You're like, okay, it needs to be continuous everywhere. Therefore, we can just conclude right away that f of x is continuous on interval 3, closed interval 3 to 5. Right. So first condition satisfied to use the IVT. Second condition here, f of 3 is equal to, let's see, so we have to find y value of those endpoints, right, 3 and 5. So f of 3 and f of 5, because we have to satisfy that our f of c equals negative 4 should be between f of 3 and f of 5. Did I write it down over here? Yeah. Right, f of c equals n should be between f of a and f of b. So when I find it, I'm not going to go over the whole calculation here, but like negative times half to the 0 power. So that gives you negative 1. And then you subtract that by 2, so you get negative 3 there. F of 5. So some of you folks are like, you probably have to review order of operation and all that, right? Especially because we're saying like half to the negative second power. It's like a power rule. You probably want to review that as well. But let's just breeze through it. So here you have negative times half to the negative second power minus 2. Right. And then I rewrote 1 over 2 as 2 to the negative first power, because they're equivalent expression right there. They're the same number. 2 to the negative first power is the same as 1 over 2. And why did I do that? Because it will make my life easier. 2 to the negative first to the negative second power using the exponent rule. You see that the power of the power will be actually multiplication of those two, right? So you get second power right there. So you get negative times 2 to the second power. If you want to be a little bit more technical, we can do that. Minus 2, that will give me negative 4 minus 2, which will give me negative 6 right there. All right, so it is satisfied that our value f of c equals to negative 4 is between f of 3 and f of 5, right? We see that f of c equals to negative 4 is between f of 5 equals to negative 6, right, which is this value, and then f of 3, which is equal to negative 3. Graphically speaking, this is going to look something like this. Let's see. 3 and 5 are 1, 2, 3, 4, 5. And then you have 1, 2, 3, 4, 5, 6, right? So we're saying when if it's f of 3, we get negative 3, right? And f of 5 is negative 6. Like here. Yeah. And our f of c equals to negative 4 will be right here. Right? So we see that if I want to, and assuming that this function is continuous, I need to cross this at least once to get there. I don't know how it looks like in the middle, but at some point we should actually go across it. Okay. So here you say f of c equals negative 4 is between f of 3 and f of 5. Therefore, there exists c, some real number c, on the interval of 3 to 5. So between x value 3 to 5, right? That's f of c is equal to negative 4. You know what? Let's be a little bit more technical here. It should be actually closed interval, 3 to 5. Because we're not supposed to include 3 and 5 here. So yeah, it should be actually there exists c, a real number c on the interval, open interval 3 and 5, that f of c is equal to negative 4. All it's saying is it needs to cross, graphically speaking, f of c equals to negative 4 at a certain point of time within this interval. All right. And remember I said just cross this out, right? Then if it's applicable, find the value of c guaranteed to exist by the theorem. So, I mean, all I really expect you to use IVT at this point of time is just, do you know if there's any x value within this interval that will get us f of that value gives us negative 4. So really this is, the application of IVT. But if you want to go further, how do you find such c value, right, that will give me negative 4? It's not something new. You folks already know how to do it. In this case, it's really easy to find that. It's not always easy. You might have to use a graphing calculator, as we'll see it in this number 2 case. So this is what happens. So first of all, you say f of c is equal to negative times half to the negative c plus 3 minus 2. So I substitute for c in f of x, the function, right? And that should equal to negative 4. So now it's equation that we need to solve. What c value will satisfy that, right? So you see that negative half times. So I want you to look at the steps that I follow there. What the heck? Let's just go over it. Okay. negative half to the negative c plus 3 minus 2 is equal to negative 4. I added 2 to both sides to get the negative 2 there. And then I either multiply by negative 1 or divide by negative 1 to get rid of this negative in front of the exponential expression. Then I get the half to the negative c plus 3 is equal to 2. I rewrote half as 2 to the negative first power to the negative c plus 3, which using a power rule or exponential rule, this is power to the power. And I get 2 to the c minus 3 is equal to 2 to the first. Oh, I have a same base here. Then this power probably needs to be same, right? I mean, it should be same exponent. So c minus 3, which is the exponent of this, and then 1, which is the exponent of that. C minus 3 is equal to 1, and c actually has to be 4. And yeah, we actually found that at 4, x value equals 4, it needs to cross that over there. Okay. So we knew from IVT that there should have been some number between 3 and 5. It could be 4, it could be 4.5. We didn't know that yet until we solved for it. That satisfy that f of c is equal to negative 4. And that c value is actually 4. So we know that f of 4 gives us negative 4. But it's not always, in this time it was easy to solve for that, right? 4 just gives out. Not always easy to solve, so that's why we need to use decimals time to time. And this is the, or graphing calculator. As you can see, this is the graph of negative, blah, blah, f of x. I'm just going to say f of x, okay? And then you will see that, let me move this guy here. Y equals to negative 4, that is our f of c value. And if you look at the intersection, just like how we algebraically derived it, it was actually 4 and negative 4, right? So x value of 4 gives us the y value of negative 4. And that is between the interval of the closed interval of 3 to 5, right? So ain't that pretty cool? Right? And you see this is the actual graph, exponential graph. So decimals helps us out a bunch, or graphing calculator, when we're trying to determine. So if I really have to draw it out, yeah, it only crosses this guy once, as we can see. It's not always the case. It could be once or twice or thrice, indefinitely. But we see something that looks like this. There's actually horizontal asymptote there, but not really important for this particular discussion. All right. So that's how you can find the C. If they ask you to find C, that's what you can do. So our C value is going to be equal to 4 exactly. Okay, so let's move on to this guy. Oh, and these 2 problems that I'm going over will be posted, so you can check it out along with the video. All right, so number 2 here. If you know how to solve number 2, number 1 will be easy. So let me just go over number 2. The number 2 says determine using the intermediate value theorem if the function g of theta has a 0 on the interval of a closed interval 0 to pi. Justify your answer and find the indicate 0 if it exists. Okay. So here it doesn't say g of c, but when they say if function has a 0 on the interval of 0 to pi, or function has a 1, or function has 5, right? Or function has a value of 5, then you have to automatically think about this. So what value of c when I take when I try to find the output using g function will give me that value. Like in this case, it happened to be 0, right? So I think I mentioned to my second period, but not fourth period. But intermediate value theorem is extremely useful when you're trying to find zeros of a function. Okay, so let's delve into it. So since g of data is, so let's look at the g of data first. So first condition that we need to look at is it continuous on the interval, closed interval 0 to pi, right? So in order to answer that, we need to know this part. So I'm going to explain this. So since we know that g of data is addition of a polynomial function data square minus 2 and trigonometric function y equals negative cosine theta, and we have established that polynomial functions and trigonometric functions, not all trig functions by the way, sine and cosine functions, those are continuous everywhere, right? So continuous for all data that is in the real number. So therefore, we know our g of data has to be continuous everywhere. Okay. I actually forgot to write that down. So here you can say, therefore, g of data is continuous. Let's just say everywhere, right? We don't have to be too formal because you know what I'm talking about right now, right? G data is continuous everywhere. So therefore, or hence, g of data is continuous on the interval, closed interval 0 to pi. Of course, because it's continuous everywhere, it's continuous in the particular interval as well. Right? So that's established. And then next thing is my g of c between g of a and g of b, right? So g of a, our a is 0 and the b is pi. So g of 0 is 0 squared minus 2 minus cosine of 0, which will give you value of negative 3. And g of pi, if you substitute for pi in your equation, then you get pi squared minus 1. Here, so we have negative 3 here and the pi squared minus 1. And a lot of you folks, when you look at the pi squared minus 1, you'll be like, oh, what to do with that? Do we need to use calculator to find what that value is exactly? Well, first of all, this is the exact value. When you're using calculator to find decimal values, those are actually approximate values, right? But before you do any calculation, just look at this part here. So you know pi square, pi is around the ballpark like 3, right? So you have something like 3 something square, which is like probably bigger than 9. And then you subtract by 1, which is bigger than 8. So you know it's a positive number, right? So only thing I really have to care about here is my g of c 0, is it between those two numbers? And without actually calculating it out, I know this is a positive number, and then I see this is a negative number, right? So my 0 should be between negative and positive. So of course that comes with experience. If you are not comfortable with this concept, you can always see what approximate value that might be, pi squared minus 1. That's a totally valid way too. But I'm just letting you know, all we really have to know is our 0, g of c0, is it between these two values? And all I had to really recognize was, oh, that's negative and that's positive. And that's where the reasoning comes here. I'll say, since my g of c equals to 0, right, is between g of pi, which is pi squared minus 1, and g of 0 equals negative 3, right? So this is greater than g of c of 0, and then this is, g of c 0 is greater than negative 3, but then less than pi squared minus 1, right? So g of c is between g of 0 and g of pi. So we can say that there exists a c, the real number c on, and let me actually change this, a closed interval 0 to pi, because we don't include 0 and pi for that c value. 0 and pi such that g of c is equal to 0. Okay. And oh, you also have to actually say this one here, by IVT. I also forgot to write that down over there, right? Here, by there exists C, any real number C on the interval, closed interval 3, 5, that f of C is equal to negative 4 by intermediability theorem. Okay. All right. In this case, how do you find the C, by the way, if they ask you to find the C? So we established that C should be between, so graphically speaking, this is 0, and then let's say this is pi, right? We know that if it was a 0, we got negative 3, right? And then at pi, we got like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, somewhere around here. Not exact value. But you see that if it's continuous, and then our f of c value is 0 here, right? So in order for me to get, or using the chicken analogy, for chicken to get from this to the other side, right, it needs to cross the road, right? So somewhere between x equals to 0 and x equals to pi, somewhere between here it needs to cross f of c equals to 0. Did I say f of c? Okay, you know what? I guess I'm still waking up. It should be actually g of c, right? Because we were talking about function g. But you know what I'm talking about. Right. So how do you find such c, by the way? I know c should be one of those values within 0 to pi, right? With g of c, so in order to do that, it's the same thing that we did it from number 5 here, right? So what you can do is g of c is c squared minus 2 minus cosine of c is equal to 0. And this, unfortunately, is impossible to solve algebraically. Okay. So we're like, oof, I cannot use this fancy step to solve it out. So this type of questions will probably come out in calculator section of AP Calculus, AB exam. Okay. So how do you do this? So right now we don't have a graphing calculator, but we do have Desmos. And using a graphing calculator or Desmos, it will give us C value approximately of 1.455, which we know it is on the interval of 0 to pi, right? And closed interval 0 to pi. Let's check that out using Desmos. So what I did was, again, draw this out, right? Y equals to x squared minus 2 minus cosine x. That's my function. So instead of theta, I use x, but it's really interchangeable. I could have used p, I could have used k, right? Like, it's basically the same function, just I use a different variable. So y equals to x squared minus 2 minus cosine x looks something like this. Oh, pretty nice function that looks like a quadratic function, right? Just to let you know, this happens because of the characteristic of cosine x and x squared. They're both even functions. So when you add those up, this is what you get. Pretty cool stuff, right? Okay, so you have like a symmetric over y-axis. And you see that if I want to see when is it equal to y equals to 0. Okay, let me move this guy. So I do that, y equals to 0. And then let's see what happens. Do you see those two solutions? That gives me y value is equal to 0. So this is another solution, but right now our interval is limited to 0 to pi. Pi is around 3.14, so it should be around here, right? So within the interval of 0 and pi, we established that there should be at least one x value, x equals to c, that will give me f of c equals to 0, right? Or g of c in this case, because we use g function. And you see that that value actually 1.455, around the ballpark. It's not the exact value. Okay. So that's how you can find it using Desmos. I'll show you how to find it using calculator later on when we have an access to that. I think we have a 90-day trial from TI-84, TI-83. That's what I heard from other teachers. So we're not going to use it right now. We're going to use it 3 months ahead of AP exam, which is around February. Yeah. Okay. So anyways, so that's how you find the x value. So here, or x equals c value. So c is equal to 1.455. So you see that g of 1, you will know that it is an approximate value, but g of 1.455 will give you a solution of 0 right there. Pretty cool, right? And 1.455 is in that interval, just like we proved it using IVT. Right. So IVT, I mean, it's a lot of writing. I mean, that's usually what proof entails, right? You need to write a lot, more than numbers. But the gist of it is there a particular C value in that given interval that will give you f of c equals to our desired value, like -4 in this case, and then in this case it was g of c equals to 0, right? Yep. All right. So I want you to try the rest of the problem and impress me, please. Always determine those two things, right, in order for you to use IVT. Is it continuous on that interval, closed interval, and then you gotta figure out g of function of a value and function of b value. Your a and b value is this guy, in case you haven't gotten that yet. And then you just have to figure out if your function of c value is between those function of a and function of b. All right, good luck. Let me know if you do have any questions. Yeah.